Hello, welcome to the video. In this lesson, we're looking at 1.5, where we're measuring and constructing angles. So we'll figure out how you can measure and classify angles. So to start with, we're going to look at how can we name angles. So here it says a lighthouse keeper measures the angles formed by the lighthouse at point M and three boats. Name the three angles shown in the diagram. So there is actually essentially there's a couple ways that you can name angles, and for this particular one you have to go with the 3 points to give it the most specific name. So in this particular one, everything that you're dealing with the angle measure is off of point M. So when you're using 3 points, when you're naming it, the vertice that's the angle that you're talking about has to be the middle term. So for the first name, I'm going to say angle JMK. So JMK, that's one angle. I can name another angle 2, and I'm going to start with K, so it's going to be angle KML. So that's another angle. Or the third here is the largest angle, which is angle JML. And if you notice, M is the middle term because it's all trying to form angles from point M. So please remember that. If you look at examples like these, it says they want you to name 3 names of each of the angles. This one here, the very first one, is relatively relatively simple in a sense that there isn't multiple angles that you have to look at. So all you have to do is look at the point that shares the common rays, and I can just call this angle Q. I can name it just one because Q doesn't define as another type of angle, unlike point M in the previous example, which it could have been a variety of different angles depending on which boat you were looking at. You could also, again, name it with the 3 points. Again, making sure that Q is the middle term, so you could say that it's angle PQR. This is the symbol for angle. Some people put a little line in there as well. I do sometimes I don't. Or I could have it flipped. I could say that this is angle RQP. The two endpoints, they can be flipped. If I look at number 2, I could certainly just call this angle Y, but because they give me a measurement here, I could also say angle 1, and I could also then say angle X, Y, and Z. Or for a fourth one, I could have said angle ZYX. That one is also works too. 3, same idea. I could say that this is angle E. I could say this is angle 2, or I can give it the 3 points in which I could say that this is D, E, F. I could certainly have said angle F, E, D, but making sure that that vertex that has the point with the 2 rays is my middle term. Here it says we're looking at a protractor postulate. It says considering line OB and a point A on one side of line OB. It says the rays of the form OA can be matched 1 to 1 with real numbers from 0 to 180 degrees. So here it says the measure of AOB, again they have O, which is the middle term, can be written as the measurement of angle AOB. So if you have measurement here, that means they want the actual measurement, is equal to the absolute value of the difference between the real numbers matched with ray OA and OB. So essentially what you're going to do is figure out what kind of an angle do you have. We'll get into the types of angles, but here this one is either going to be 40 degrees or it's going to be 140 degrees. Since uh, in this case I'll get a little ahead, it is larger than 90 degrees, I'm going to say that this is going to be 140 degrees from the reading of the protractor. So with that, we have some classifications. So anytime you are asked to classify an angle, here are the different types. You can have an acute angle. Acute angle is any angle measurement that is between 0 and 90 degrees. You can have a right angle, which measures exactly 90 degrees. Sometimes it'll say 90 degrees. A lot of times you'll see this square box on the end that's supposed to establish that it's 90. An obtuse angle is anything that's in between 90 degrees and 180 degrees, and a straight line or straight angle is exactly 180 degrees. So with that, we have a protractor here. We're given a series of angle measures. They want us to classify each angle. They want us to find the measurement of each angle. So first off, I have GHK. GHK, that one is, it is going to be an obtuse angle, and it's larger than 90, so it's between 120 and 130. I'm going to say that's 125 degrees. For part B, I got JHL. JHL, that is 90 degrees. That's a right angle, and it's exactly 90 degrees. Now I have LHK. Let's see here. Oops. Let me erase these. LHK. Now, this one here is an acute angle. And this one's interesting because we have to take the difference. So in here, this is going to be, looks like 90 minus 55 in order to establish what that angle is. And 90 minus 55 is 35 degrees. So again, this is kind of the same directions as the previous one. Once you find the measurement, classify. I encourage you to try them yourselves. If you have questions, please comment down below. More than happy to answer your questions if you seem stuck or are just not sure. Here it says identifying the congruent angles labeled in the quilt design. So if you look here, we have two distinct shapes with with vertice with vertex points. So we have a polygon EFGH, which is right here, and we have a polygon ABCD, which is right over here. Now, kind of like what we had with our like hash marks with side measurements, we have kind of like hash marks with angle measurements. So if you look at, say, angle B, and it's got the one marking, the red marking there, and you see that same marking here in angle G. So I can go about and say that angle B is going to be congruent to angle G because they gave us that information. Looking at another one, I can also say that angle D is congruent to angle F. All right, so with that being said, they're saying that ADC is 140 degrees. So ADC is 140, so that's 140. They want you to find the measurement of EFG. So they're telling you that since those are the exact same, I can say that this is also going to be 140 degrees. Here we have what is called an angle addition postulate. So what they're stating here is that if P is an interior of angle RST and you have the measurements of RST and that's going to be equal to the sums of angles RSP and angle PST. So actually if we even looked at that first example that we had here, you could say that JML is going to be equal to whatever that angle is. It's going to be equal to JMK plus KML by using that postulate. All right, so now that that is given to us, let's see here. It says given that LKN is 145 degrees. So I'm just going to make this like a little here. I'm just going to put 145 degrees. They want you to find LKM and they want you to find MKN. So in order to do that, we'll implement that angle addition postulate and we can say that 2x plus 10 plus 4x minus 3 will then equal 145 because the whole thing. Combine like terms, I got 2x plus 4x, 6x, cross it out, cross it out. I got combined terms here, that turns into positive 7, that equals 145. 145 subtracted by 7, I get 6x equals 138. Divide everything by 6, x equals 23. Now, again, we got to figure out what they're asking. They're asking for the measurements of angle LKM, and they're asking for the measurements of angle MKN. So 23 is not the answer that they're looking for. It just helps us find the answer. So angle LKM is essentially going to equal 2 times it by 23 plus 10. So 2 times 23, 46 plus 10, 56. So LKM is 56 degrees. So that's 1. And then I go here and say MKN is going to be equal to 4 times it by 23 minus 3. So 4 times 23, 92, subtracted by 3 89. So I have 89 degrees. To check it, make sure that 56 plus 89 equals 145. It does. All right, so here it says given that angle KLM is a straight angle, so they're telling us that's a straight angle, so that indicates that that is 180 degrees. They want us to find KLN and NLK. So same idea. You're going to use that angle addition postulate. So you're going to take 10x minus 5 plus 4x plus 3. And the result of it is going to be 180 degrees because they told you it was a straight angle. Combine like terms, I get 14x. We want minus 2 is equal to 180. Add 2 to both sides. So I got 14x is equal to 182. 182 divided by 14. I get 13. So just like the previous answer, this doesn't, that's not the answer they're looking for. They want us to find the measurements of KLN and NLM. So looking at this portion of the problem, I can substitute 13 in for x. 10 times 13 is 130 minus 5 is 125 degrees, which is over there. 13 times 4, 52 plus 3, 55, so I got 55 degrees. And you can just double check 125 plus 55 is in fact 180. So this is kind of the same issue. They're just telling you this is a right angle. They're telling you that this is then 90 degrees. I encourage you to look at it. Again, if you are stuck, please comment down below. I'm more than happy to help. Final final question. Here it says QS bisects angle PQR. So let's draw this out. So I have an angle here, PQR, and it says that QS bisects it. So it's right here. So this is the point S. When it says bisects, what that means is it cuts the angle in half. So whatever the value of this measurement, PQS, is going to be the same as this measurement, SQR. So they're telling you that the measurement of PQS is 24 degrees. They want you to find PQR. So that's the whole thing. So because they told you that it bisects, that means that this is going to be also 24 degrees. So to find the measurement of angle PQR, you're simply just going to take 24 plus 24 because you're just implementing that angle addition postulate, and it is going to be equal to 48 degrees. And that is being able to measure and construct angles. Hope this helps. Till next time.